Okay, so we are almost done with ionic compounds. There are these things called ternary compounds or tertiary. What that means is they have more than two elements. So binary, which is what we've done so far, they only had two elements. They only had two capital letters. That's how you know you were dealing with that. They were either type 1 without Roman numerals or type 2 with Roman numerals, and then they had nonmetal anions. At this point now, we're moving on to ionic. They're still ionic, but what they have is they have these things called polyatomic ions. They're ions that are made up of more than one atom. They're kind of lumped together in a giant conglomeration, but behave like one of your anions before. So there's a bunch of them. They are either anions or cations. Actually, there's only one cation you need to worry about. They're made from more than one element, but they act like just one atom kind of thing together. So polyatomic cations form compounds just like metal ones. The only one I know of is ammonium. Polyatomic anions form compounds just like nonmetals do. And the charges have to balance, in other words, drop and swap. The names for the polyatomic ions, here's one of the big clues for you. They don't end in IDE except for hydroxide, which you're going to see a lot of, peroxide and cyanide, which you won't see as much of, but hydroxide in particular you're going to see a lot. So IDEs are on the periodic table, they're elements. So sulfate, here's an example of a polyatomic ion. This whole thing, this SO4 thing, behaves just like S2- when it drops and swaps with, say, sodium or something else. It behaves as one atom, and the charge drops and swaps. Okay, so sulfate is SO4. I'm going to erase the ink. And then ammonium is NH4 1+. So this is the only cation I know of. It behaves just like Na1+. It behaves like that, except it's a group of atoms bunched together. So here are the common polyatomic ions. I will give them to you. Okay, the ones that have the little asterisks are the most common ones, and you're probably going to see them more than any other one. So when you write formulas with polyatomics, you're still going to do the drop and swap that we've been doing all along. For ionic ones, that's what you do. It's easiest to put the polyatomic ion inside parentheses and put the charge outside and then drop and swap. So, for example, sodium sulfate. Sodium, 1+. Sulfate, I'm recognizing that because it ends in ATE, that it is not just sulfur. SO4, charge on the outside. And then you're just going to drop and swap like before. So you've got it like this. Drop and swap. The 2 drops here. The 1 drops here. Notice I didn't do anything with that 4. So technically it's Na2SO4 1 or Na2SO4. Or you could even drop parentheses if the number outside is 1. So any one of those answers is acceptable. Okay, I'm going to do it this way when I put it as a multiple choice or something like that. But any one of those is acceptable. But notice in particular that 4 just stayed right inside that parentheses and didn't go anywhere. Okay, so let's practice these. So nickel 1 is nickel 1+. Chromate, look back, it ends in ATE, is CrO4, parentheses 2-. Drop and swap, Ni2CrO4 1. And I'm gonna leave that up there for now. Okay, potassium carbonate, K1+, carbonate 2-. Drop and swap, you get K2CO3. And again, I'm going to leave the 1 there just because. Okay, ammonium, be real careful. Okay, this is not the AM that you see on the periodic table. That's americium or something. That's radioactive. Nobody ever uses it. Ammonium is NH4. It's the positive polyatomic ion. Hydroxide, this is a trick. Watch for that. It ends in IDE, but it is definitely a polyatomic. 1-. When you drop and swap 1s, you end up with NH4OH or NH4OH. Don't combine the H's. Keep them separate. So calcium acetate, Ca2+. Acetate is a long one. All of it in parentheses. Drop and swap. Notice I'm going to keep the 2 there. I have to keep the 2 there. I can't drop the parentheses and I can't drop it. Okay, here I could drop the 1s. Copper 2 phosphate is Cu2 plus because of the Roman numeral. Phosphate is PO4 negative 3. Drop and swap Cu3. Let's make that a 3. PO4 2. Okay, you have to leave them there. If you can simplify, so in this case I had 1 and 1, it simplifies. But if I had 2 and 2, I could definitely do that. I could definitely simplify. Go ahead, take a minute, see if you can practice these. Watch the endings, okay? Not all the ones on here are polyatomics. Okay, just be careful. So for the first one, ammonium, that's the NH4. Bromide is not on the polyatomic chart. That means it comes off of the periodic table. So when you drop and swap this one, you get NH4 ER, and I'm going to leave it in there for now. Sodium carbonate tells me it's from sodium and carbonate. When I drop and swap, I get Na2CO3. Okay, I'm going to drop the parentheses in the 1. This one, zinc 2 hydrogen sulfate. Look for this one carefully. Okay, Zn typically is always a positive 2 charge. Hydrogen sulfate. Look for it on that polyatomic chart because it ends in ATE is HSO4 negative 1. Drop and swap, you get Zn HSO4 2. Okay, copper 1 phosphate. So notice it's Te, not De. So Cu 1 plus. Phosphate is PO3 3 minus. Drop and swap. Since there's a 1, I'm going to leave the parentheses and the 1. You don't have to, but I'm just showing it to you so that you don't get confused. Magnesium hydroxide, Mg, positive 2, OH. Watch for that one. IDE, still it's a poly. So Mg, OH, 2. This one is probably the #1 thing people screw up. They forget the parentheses here. Okay? Put the parentheses around it here, and then you won't need to worry about forgetting it. Iron 3 hypochlorite, Fe3 plus. Hypochlorite is ClO, 1 minus. Drop and swap, you get FeClO3. This is different than that. This is iron 1, which there is no such thing. Iron 1 chlorate. This is iron 3 hypochlorite. Okay, the 3 is outside the parentheses as opposed to right next to the O. Pay attention, that's a trick question. Alright, naming them is probably the harder part. You need to name the cation. You need to name whatever's written first. If it has to have a Roman numeral, you have to do it, and that's the hard part. And then you just name the anion, you pull it right off that sheet of paper. Okay, you do have to do the algebra, and you do have to recognize that it's got a polyatomic. If it has 3 or more capital letters, that's how you know. You need to look on that little chart. So, 3 or more elements, 3 or more capital letters, that means you're going to look on that chart. Okay, that's where you need to go first. And then I'll give it to you. So, I'm looking at all of these, and every single one of these except this one, which is CrCl3, all of these have a polyatomic ion, except that one. 2 capital letters. That's an L. So, that means I need to look on my little chart, and I need to look at this and see, all right, do I see anything there that says Ca? No. That means Ca is just calcium. Now I look up the NO3, and I look on that chart, and NO3 is nitrate. Done. Calcium does not need a Roman numeral. It's done. So I look at this one, 3 capital letters. I look for sodium. I don't see it on there. So sodium. I look up this half of it. Even though it doesn't have parentheses, I have to be able to recognize it as being a polyatomic ion. So SO4 has the name sulfate. Sodium does not require a Roman numeral. Next one. Again, I look up the first, I see 3 capital letters. I look on that chart. I don't see Al, so that means it's aluminum. I look up OH, it's hydroxide. Again, does not need a Roman numeral. Again, 3 capital letters. RB is not on there, so rubidium. PO4 is phosphate. And again, you have to be able to recognize that whole beastie as being a polyatomic ion. I'm going to do those two last. I'm going to jump up here and do this one. Okay, so I'm looking at this one. I see 3 capital letters. And I notice that NH4 is on my chart. Unlike the calcium, sodium, aluminum, rubidium, NH4 is on my chart. That means it's my polyatomic ion. That means Cl is not. And it comes from chlorine. Drop the ion and add IDE. Okay, so I want to point that out to you. Watch for that. That does happen. Only with ammonium, but it does happen. And then I'm going to jump down and do this one too, and probably this one before I go to the other ones. Okay, it's not on my chart, but I see 3 capital letters, so potassium hydroxide. Okay, here I only see 2 capital letters. That means I go back to my old rules. Chromium, chloride, IDE, and I need the Roman numeral. -1 times 3, x plus that adds up to 0, means it's Roman numeral 3. Okay, so when you have to do a Roman numeral, you have to do the algebra backwards, and it is tricky. It is very tricky with these. I'll do it here. So copper, ClO2 is chlorite. Notice, geez, I was going to say that, and I just wrote it instead. It's different from IDE. It's ITE. Spelling does count for that. Okay, so chlorite. Now, I need to figure out the Roman numeral on this. And since this one has parentheses, what that means is it has a charge of -1. This whole thing, and there are 2 of them. So I'm just going to put the parentheses around the whole thing, times 2. X plus -2 equals 0. Roman numeral 2. Okay, this one is iron. That whole long thing is acetate. And again, iron needs a Roman numeral. So this whole thing has a charge of -1, and there are 2 of them outside here. So X plus -2, iron 2, acetate. So those aren't too bad. Those are actually not so awful because the parentheses are built in there for you. But when I get to these next 2 over here, you need to be able to look at them and go, oh my God, 3 capital letters, that means it's a poly. So nickel sulfate. But then you need to personally put in the parentheses here and here and recognize that the number outside the parentheses is a 1. Okay, if there are no parentheses, the number outside is a 1. That is a guarantee. So you need to personally do that. Then you can figure out the polyatomic, or the charge on the metal. So sulfate is -2. There are 1 of them. X plus -2 equals 0. Roman numeral 2. Okay. This one, chromium, phosphate. Okay, again, I know it's got a polyatomic in it because I see 3 capital letters, but I don't see any parentheses, so I'm physically going to write it in there, and I'm going to put that 1 there. Then I can do the charge on the metal, the transition metal. So phosphate is -3. There are 1 of them. X plus that has to equal 0. Chromium 3, phosphate. Both of these instances are where they have been reduced. So you cannot easily undrop and swap them. Both of these. Because it was a 2 and that was a 2, they dropped and swapped and reduced. This was a 3, that was a 3, they dropped and swapped and reduced. Those are hard. Okay? Follow the steps and you should be okay.